Hey guys, in the last video I showed you how to load and save your data so that it's ready for MATLAB. In this one I'm going to try to show you what each data file contains, just so that you can understand what we're actually exporting. So you see here the files that I just renamed. If I open one, I'll be able to see what's in the data file. Now the first time you open this on your computer, most likely it will open in Notepad. So just to make sure you can see it in Excel, right click, click on Open With, and then Excel. So it'll open the data file and you'll see a whole bunch of information. So I'm just going to make this a bit bigger so we can see. All right, first line is the actual file name that we used when we did the measurement. So just in case something goes wrong, you can always see what the original file name was. Second, we have the date with the time, and this timestamp is actually really important to be able to synchronize our data later on. Then where we did the measurement, some of the configuration. So here is which detector did we use, also which detector. And then there's this section which is really important. So this is the regions of interest. So this is the peaks that we're trying to analyze later on using our MATLAB code. So for the K alpha of arsenic, we're going to use these energies, and we're going to do the same thing for all the others. So K beta, iron K alpha, and iron K beta. Then when we're doing an angle scan, we're going to go from 0 to 60 degrees. Here the values are negative, but we just put them as positive. And we used 5-degree increments. I know it says millimeters, but this should actually be degrees. It's just a problem with the software. Position is not that important. Some of the parameters that are used during the measurement, so what kind of beam is used, the beam energy. So you'll notice this is not exactly 13.5, so this is the real energy, even though we input 13.5. Some of the other parameters that we don't really need, and then some of the settings for the detector. Now, although these in themselves are not that important, what you should note is that these values here should be the same for all measurements. So in the previous data analysis, there was a problem with some of the values looking really weird, and it turns out that one of these values had changed before the measurement, and that's why everything was off. So if something is wrong and you're trying to troubleshoot, make sure these values are the same. Okay, then we have the important data, or the numbers, which is all of these guys. Now realistically, we don't need all of these. The first column, which they call RZ, is basically the angle. So you'll notice it's going from 60 to 0 in 5-degree increments. So these are the angles that we're going to need. Then you have something called ASK alpha. So this is the actual values for the arsenic. Now the next column actually normalizes these values for the detector. That way you're normalized the same for everything. So the value that we're actually going to use when we're doing our analysis is this one here. So the normalized value. And it does this for each region of interest. So here, arsenic K alpha, normalized arsenic K alpha, arsenic K beta, normalized arsenic K beta, and so on. So basically, when we're doing our analysis, the important values are going to be the angles, the normalized K alpha for arsenic, normalized K alpha for beta, and the same thing for the iron. So now you know some of the basic information that are in these data files.